Hello and thanks for watching Best Maths Tutors. I'm continuing to go through the Edexcel A level paper 1 from 2018. I'm on question 6. And hit the subscribe button if you'd like to see all the rest of the videos on this paper. So what we've got is a circle, C here, that's got a centre A with coordinates 7, 5. And we've also got a line L with this equation, y is 2x plus 1. So that's y equals 2x plus 1, and what we're told is that it's a tangent to the circle at point P, and we've got to show that the equation of the line PA, so the line going from P to A, is 2y plus x equals 17. So the first thing that we're going to need to do is find the gradient of the line PA. So to do that, we need to find the gradient of, first of all, the line L, which is y equals 2x plus 1. So that's easy enough, because if we use our general equation, y is mx plus c, then we know that m is the gradient, and since we've got y equals 2x plus 1, then we can see the gradient of L is equal to 2. So that's that, first of all. And then we know that if we've got a tangent, which is what PA is, to this point, this line L at point P, we know that it's at 90 degrees. And so we have an equation for two gradients which are at 90 degrees. And so if the two gradients were at 90 degrees, if I've got gradient M and I've got gradient N, if they were at 90 degrees, then what we could say is that N would be equal to minus 1 over m. So it's the negative reciprocal. So if we call in the gradient of line PA, the n, then we can see that the gradient of PA is actually going to be minus 1 over the gradient of line L. So it's going to be minus 1 over 2. So we found that, first of all. I'm just going to move this up a little. So having found our gradient, we're now going to apply another equation for a straight line, which is that y minus y1 is equal to m, the gradient, x minus x1, where x1, y1 is a point that the line will go through, and m is the gradient. Okay, so this is for a line going through the coordinate x1, y1. Well, in our case, x1, y1 is actually the center of this circle here. So the coordinates of x1, y1 are 7, 5. So we can say these are the values we're going to put into our equation here. It's 7, 5, and the value of m that we're going to use is this one that we got for PA. So that's going to be minus a half. So if we substitute all those in, we're going to get y minus the 5 is equal to the gradient minus a half, and then times by x minus 7. I'm going to move this down a little bit, just give myself a little bit more space. So if I multiply that out, I'm going to get y minus 5. In fact, I'm going to multiply through by 2, I think would be easier. So multiplying both sides through by 2, I'll get 2y, and then minus 10. So multiplying the left-hand side by 2 is equal to minus x, and then minus times minus is going to give me positive 7. So we're actually close to the required format there. So I'm just going to add x to both sides. 2y plus x minus the 10 is going to equal 7. And then if I add 10 to both sides. Then what that's going to give me is 2y plus x is equal to 17 as required. For the next part of the question, we've got to find an equation for C, which is the equation of the circle. And we're going to use the formula, general formula for a circle, which is that x minus a all squared plus y minus b all squared is equal to r squared. And this is for a circle through the point A, comma, B. So if we've got a coordinate of the centre of a circle as we have here, we've got 7, 5 in our case, 7, 5. That's our A and B, that's the centre of the circle. And R is the radius. So really, ultimately, what we're going to have to find is, in this case, that's the length of PA. So we could write this in part already. So we could actually write that it's going to be x minus the x coordinate of the centre of the circle, so x minus 7 all squared, plus y minus 5 all squared, and that's equal to r squared. But what we need is we need to find the value of r here. And to do that, we're actually going to need to find the coordinates of point P. So the first step, or the next step in this actually, is to find the coordinates of P. And that's the point where the line y equals 2x plus 1 and the line 2y plus x equals 17 intersect. So in order to do this, what I'm going to do is I'm going to substitute in the 2x plus 1. I'm going to replace it in the replace the y in the other equation by that, and then I can solve it for x. So what I'll get is I'll get 2 and then 2x plus 1 plus the x equals 17. So if I multiply that out, what I'm going to get is 4x plus 2 plus the x equals 17, and then 5x plus 2 equals 17. Take away 2 from both sides, 5x equals 15, and so divide by 5, you can see that x equals 3. If I then replace the x here by the value we've just found, then what we'll get is that y is equal to 2 times 3 plus 1. So we can see that 2 times 3 is 6, plus the 1 gives me 7. So I've got y is 7. So that means the coordinate of P is actually 3, 7. And from that, I can find my radius, and my radius there of the length PA which is r, is going to be given by r is equal to actually the square root of, and then it's the difference in the x values. So that's going to be the 7, and this point here is 3, 7. So the difference in the x values there is 4. So 4 squared, and then plus the difference in the y values squared, which is 2. So plus 2 squared. So we can see that r is equal to square root of, and we've got 4 squared is 16, plus 2 squared is 4, so root 20. But in our equation, we actually want r squared. So we can see r squared is root 20 squared, which is just 20. So I'm going to just put this in here now. And what I'll get is the equation of my circle. C is that x minus 7 all squared plus y minus 5 all squared is equal to 20. So that's part B done. And now we're on part C. And what we've told is that there's actually another line now, y is 2x plus k, where k is not equal to 1. So this one that we were looking at previously is y equals 2x plus 1. But we've now got another line which is also a tangent to C. So if the value at the end, the number part, is different, so k does not equal 1, but it's still a tangent, it's actually going to have the same gradient as this line, and the only way it could be a tangent would have a different value, different number at the end here, would be if it was a tangent on the other side of the circle. So if it looked like that. And so these two lines are actually supposed to be parallel here. They're not quite, but they're supposed to be. So we need to find this coordinate then, and then we can apply y equals mx plus c. In fact, we can apply y equals 2x plus k to this point when we find it, and that will allow us to find the value of k. So through the fact that this is a right angle, and if we was to extend this radius across the circle to here, then due to the fact that that's a radius and that's a radius, they're going to have the same length. So we've got actually similar triangles there. And I'll just change colour so we can just see the similar triangles. We can see that actually this triangle here is going to be a similar triangle to this one here, or in fact congruent triangle. If we look at the difference in the y coordinate between this point and this point, you can see we go from 7 to 5, so that means that distance is 2, which means this distance is also going to be 2. So that would mean that we'd subtract a further 2 from the 5 here, the y coordinate of point A. So that would mean that the y coordinate of this point here is going to be 3. We use a similar process of logic. We can see that we've gone from an x coordinate of 3 there to an x coordinate of 7. So that means that length there is actually 4 in the x. And so we're going to move along another 4 from A to the x coordinate here. So since the x coordinate of A is 7, if we add 4 onto that, since this length is 4, it's now going to be 11. So we've got the coordinates of this point here. We can now substitute these two values of this intersection point into this, and that should find us the value of k. So we're going to have 3 being the y value is equal to 2 times 11 being the x value plus k. So we get 3 equals 22 plus k, and if we rearrange that, k is equal to 3 minus 22, which means that k must be minus 19, and that's it. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel for more of our videos. Thanks for watching.